Gifts. We love to give them, and it's almost Christmas, meaning it's Now, if everyone already knows I'm a lab hermit who builds stuff, why not build a gift that actually gives whoever receives it an entry-level experience into robotics? Presenting Tobee, your tabletop robot. Not yet in the flesh, of course. I initially wanted to build my very own emo robot, but after some financial and part availability constraints, I decided to chill out on that for now. Tobee, which is a tabletop companion robot, is designed to be a 2 degrees of freedom robot with a rotating base and a screen as an end effector. Tobee will have either eyes that react to the controls you manually give to the robot, similar to the emo robot, or you could also just program in your friend's favorite quotes to motivate them, in times of play, I guess, with the robot. I couldn't come up with a better name, so if you do have one, drop a comment with it and I might just change the name. But if you love Tobee as the name, just comment Tobee, and if you get enough traction, I'll keep it. Also, don't forget to like and subscribe if you want to see more robotics projects like this here at Legends. Now that Tobee V1 has been established, let's get over design considerations and constraints. Starting off the project, I made a hand-drawn draft detailing the joint positions and considering the materials I'll need. I ended up with this crappy looking draft and started working with that. In order to have a valid design, I laid out all the different components, which included a 1.3-inch OLED screen, 2 N20 motors, one for the rotating base and the other to rotate the screen, 2 SG90 servos to actuate the joints, an Arduino Nano ripped from an old project remote I made a long time ago, 4 potentiometers, an L298N small form factor motor driver I had laying around, a Type-C port, a charge and discharge module for the LiPo battery, a switch, a small piece of Vero board, some servo connector wires and some headers. With this sorted out comes the next problem, of course, the design. Normally I would design test parts, print them and then use the measurements for parts that fit to the design to design the actual final product. But instead, I went ahead and did the final design. This was with the intent that I could just adjust the dimensions after I print the part in case it didn't fit and I would just be okay. Foreshadowing, let's see. Nonetheless, I popped open Fusion 360 and got to work. I started out by measuring the components' dimensions and making my 2D sketches. I created the components starting from the screen holder, which is screwed on a back plate that had a slot for the N20 motor that would move it. At the back of the N20 motor slot, I created a cover that would also have a print-in-place joint to work with the whole screen movement mechanism. I progressed to designing the first link that will connect the motor to the end effector screen. And yes, I love me some symmetry and curves. At the end of the link, I added the motor mounting section and made the second link also in a similar way. The most annoying part of designing the links were the motor mount and shaft mounting sections, due to the difficulty of the dimensions from the SG90 servos. But after looking up some datasheets online and adding my own made measurements, I arrived at this. With the second link quickly done like the first, I added another motor mount and attached it to a round plate. This would rotate at the base. To make the rotation work, I added 2 gears with a ratio of 2:1 so I can get double the torque from the N20 motor. I designed a shaft that would hold the bearing on the large gear for smooth rotation, and I also designed the mounting section for the N20 gear motor. With those parts done, I made a cutaway section where the potentiometers will be housed, similar to a control box, which was housed in the overall full base for all the electronics. Now, I'm aware the wiring holes aren't done, all the parts aren't designed for 3D printing friendliness yet, and parts like the Type-C port and a lot of other things like the rounded edges are also missing. But by the next updates video, you should be seeing an actually done Tobee, fully working in the flesh, or rather in the plastic. If you've watched this far, thank you for watching. Leave a like, subscribe, and see you in the next upcoming videos where I'll be showing off Tobee completed. With that, see you in the next one.